I'm Jeneetha, EC Department, Panimala Engineering College. So today I'm just going to discuss on error control coding. So error control coding is a technique which is mainly used in digital communication in order to reduce the error which is going to take place in the transmission of the signal from the transmitter to the receiver. But before studying what exactly is error control coding, we'll see why we are supposed to go for error control coding. So we know very well the digital communication, we are just going to transmit the digital signal from the transmitter to the receiver. So I'm just considering a simple digital communication system wherein I'm considering the cellular tower as well as a mobile device. So the digital signal will be transmitted from the cellular tower to the mobile device. In designing such a digital communication system, my prime concern should be to minimize the power transmitted per bit. So why should we minimize the power transmitted per bit? So here we can see the receiver is a mobile device, and we know very well the mobile device is a battery operated device. So if in case the power transmitted per bit is very high, the battery will be drained for every 5 minutes, and we need to recharge the battery very often. So our prime concern is to reduce the power transmitted per bit. So once I reduce the power, I can just have the life of the battery for a longer time. So by applying error control coding, what I can achieve is a 9 dB improvement in the power transmitted per bit. So once I say a 9 dB improvement in the power transmitted, the 10 times power decrement will be obtained. So the next applications where error control coding is used is the storage device. So we know very well we have various storage devices. So say for example, I'm considering the CD as well as the DVD. So whenever I'm designing the storage device, my concern should be to optimize the number of bits per square inch. So once I say optimize, it should be as long as possible, or the number of bits per square inch should be a larger amount. So we'll see why. Say for example, I just want to store a HD movie which is large value. What I prefer is the entire movie should be stored in a single CD. This I can achieve only if the number of bits per square inch is very high. So by applying error control coding, what I can achieve is a greater increase in the number of bits per square inch. So once the number of bits per square inch is greater, the storage capacity of any storage device will also be greater. So I'll be able to store more data in it. So nowadays, we know very well communication is found everywhere and storage devices are also found everywhere. So what I mean to say is error control coding is everywhere, and it is a nice and interesting topic to discuss. So now we'll see what exactly is error control coding and why we should go for error control coding. So error control coding, as the name indicates, we are supposed to provide a mechanism to control the error. So in digital communication, we know very well the digital informations are getting transmitted. So once I say digital informations, I'll be having only two levels, either a high level or a low level. So once it is getting transmitted through the channel, we know very well the signal will be subjected to noise. So there are possibilities of my message signals to be changed. Since I have only two levels, the noise which is getting introduced will be very high. So in order to minimize this, we are supposed to provide a mechanism. So error control coding, we have two different types. One is ARQ, the second one is forward error correction. So ARQ stands for automatic repeat request. So in this method, the transmitter will be transmitting the binary data and the receiver will be receiving it. Again, it will be asking for retransmission of the same data. So once the same message is retransmitted, it will be compared. On comparison, the errors will be detected and it will be corrected. Whereas in forward error correction, we are just going to provide a mechanism to detect the error and correct the error while transmitting the data itself. Hence, it is called as forward error correction. So now we'll see how this is applied. So I know very well the data what I'm going to transmit or the information signal is digital in nature. So for example, I'm just considering a message which is of the size k bits. So it is just going to transmit k number of message bits. So first, it is applied to the channel encoder. This channel encoder plays a major role in error control coding, especially in forward error correction. So the function of this channel encoder is to accept k number of bits and convert that into n number of bits such that n is always greater than k. So once I say so, the input to the channel encoder is k bits, output is n bits, and n is greater than k. So what is the function which is taking place in the channel encoder? So channel encoder obviously adds some extra bits, and those extra bits are called as redundant bits. And this redundant bits plays a major role in detecting the error and correcting the error. This channel encoder can be any one of these types. It can be designed using linear block codes, cyclic codes, or convolutional codes. So now the input is k bit message, the output is n bit, and this is called as the code word. So in the middle, we are just going to add some extra bits, which is called as the redundant bits, and those number of bits which is added, I am considering as q, and my q will be n minus k. And after encoding, it is passed through the modulator for proper transmission of signal through the channel. So now, once my signal is getting transmitted through the channel, it will be subjected to noise. So at the receiver, we are demodulating and we are giving the signal to the channel decoder. So the main function of this channel decoder is to detect the error and correct the error. And this function will be done with the help of the redundant bits what we are adding in the transmitter side. So the channel decoder will be checking for the error, and if in case there is any error, the channel decoder is going to correct the error. So finally, I'll be getting back my original message signal. So by applying error control coding, we'll be able to get a control over the errors which will be taking place in the channel. Thank you.